All right, page 5 in your booklets on the grouping method that deals with the second type of factoring. All right, so as you know from last day, anytime you look at a question, you will determine what type of factoring it is, generally by how many terms there are. However, common factoring, which is the one I did yesterday, can have any number of terms. So therefore, this one, you're always going to want to check, could I common factor it first before I do any other kinds of factoring? And sometimes it'll common factor and then it'll factor again using one of the other methods I'm going to teach you. Or it may not common factor at all. All right? And then after that, you have to determine what type of factoring you have according to the number of terms you have. Right? So today, under 4 terms, we're going to have what's called grouping. Okay? Grouping is only 4 terms. You will never see grouping with any other amount of terms. It's always 4 terms. So if you have 2 terms or you have 3 terms, you cannot use this method. All right? I also ended up giving you kind of this orange sheet. Okay? Step number 1, ask yourself, is there something common that can be pulled out? And I give some examples of it. Then after that, step 2, how many terms does it have? You're going to choose from the following. We're going to talk about difference of squares one day. Today we're going to do this one down here in the corner, grouping. And then there are really 3 different ways for trinomials. I teach the first one and the last one. The reason I don't teach trinomial squares anymore is because you can use this method to solve for it. And so this one I just I'll breeze through that one because there are ones that are pretty easy ones to identify. But decomposition pretty much takes care of these other 2 methods. And so once you learn decomposition, the other 2 methods you could get rid of them if you wanted to. However, this is faster. But we're going to talk about grouping today. So the key thing with grouping, 4 terms. Okay? That is a must. Okay? Essentially what grouping is common factoring twice. Okay, so we're going to common factor twice. Okay. What is left in the brackets? Like when we common factor, we end up with brackets, right? The leftovers in the brackets. What's left in the brackets must be the same. So these ones actually kind of self-check themselves, that if you can't get your brackets to be the same, you've done something wrong. Okay, so grouping, because grouping things is like taking some from this, putting it over here, and taking something from somebody else, putting it over there. So that's why it's called a grouping method. We're going to common factor twice. All right, so question number 1. So if we look at this question, we always tackle every single question asking myself, can I common factor it, right? Well, there's 4 terms there, which I could common factor, but you'll notice that there is not a number that's common between all 4 terms. There's not a variable that's in all 4 terms, right? And therefore, the common factoring method actually doesn't work in this case. So then we go to step 2, which says, how many terms are there? Well, grouping. So that's where we're going to go. So this is how grouping works. Okay? You are going to common factor the first 2 terms only. Okay? So we're going to only look at these first 2 terms. Okay? I'm going to ignore the other 2. So I'm going to cover them up so they're not even there. Okay? So I'm going to ignore these ones. Make sure the sign goes with it. Okay? I'm going to ignore that one and pretend that's my question. Okay? Then I'm going to use common factoring because that's what grouping is. It's just common factoring twice. Well, I have an xy plus a 3x. That means I can remove an x and be left with a y plus 3. So far, so good? Okay? Well, grouping is common factoring twice. So now that I've done the first two brackets, I should probably do the last two brackets. But the lovely thing about this is, as I stated before, what is in the brackets has to be identical. So when I'm looking at common factoring this, I need to have what's left in the bracket to be a y plus 3. Well, in order for me to have a y and a 3 there, I have to remove this 2. Right? So I have to remove a positive 2. The sign must go with it. Make sure you put a sign with it. So if I remove this 2 out of both terms, I will get y and a plus 3. Are these two brackets the same? Okay. Once they are the same, we write them once. And then the other one that's in front, these two things that we factored out in front, become the other binomial. That is why this sign is important. If you don't put this sign in, then what does it look like when I put it in here? Right? So you don't want multiplication, you don't want that. So you go x plus 2.
That's it.
So yeah, these will end up being binomials. Remember the foiling process when you foiled things out and one of the binomials had one letter in it and the other binomial had another letter? Those middle terms didn't go together. That's what the grouping is. Because when we FOIL something out, right? Let's say x plus 4 and an x minus 3. When I go first, outer, inner, and last, my middle terms generally went together, right? And I was ending up with a trinomial. These are the cases where I have one variable and I have a different variable. xy, negative 4y, positive 3x, negative 12. Now my middle terms don't go together because one's a y, one's an x. This is the backwards of that. So there will always be binomials, right? Your answer is always going to be two binomials. Two binomials. Actually, all of these methods that we have at the bottom of this orange sheet, difference of squares, grouping, trinomial factoring, trinomial squares, decomposition, are all 5 of those methods are going backwards from the FOIL method. In algebra, there's one way of getting there. First, outer, inner, last. That's all you're doing. You're foiling them. That's it. But there are 5 methods to go backwards, depending on what the answer looks like. All right? So when you FOIL a question out and you can't put the middle terms back together, you have to use grouping to get backwards. All right? So this next one here, they're going to sometimes show you a question that looks like this. And in reality, they've done the first step for you. Do you see how this step right here looks identical to that step right there?
Yeah.
The 2 brackets, right? And then we have something in front, we have something. So the first step is already done. So we can just write our two binomials, an x plus 3 and a 5y minus 4. And it really makes no difference which one you write first. You could write 5y minus 4 and an x plus 3. Makes no difference, right? Multiplication is either or. I tend to write my brackets first, then I write what's in front together. Not a big deal. All right, let's look at number 3. So again, I asked myself, can I common factor this? Is there something that's common between all 4 terms that I could remove? No. Therefore, I go to one of my methods. Since it's 4 terms, the only method I can use is grouping. Means I'm going to ignore the first part, all right? I'm going to ignore the last 2 terms, and I'm just going to group the first 2. It's important that you group you common factor the first 2 terms correctly, otherwise you can't get those brackets to match up. So I can remove a 2 and an M. All right. Once I remove the 2M, I'm left with a K in this first term and a plus V in the second term. So far, so good? So I want to end up with just the K and the V. Everything else is what I need to remove, right? Means I need, and it's a positive K and a positive V. I've got a negative, negative. That means I need to remove that negative, and I also need to remove the Y. That leaves me with the K plus the V. And then my final step, write my 2 binomials. K plus V, 2M minus Y. Okay. Look again. Have you try it out? So again, you're only looking at your first 2 terms. That negative goes with the 3, right? Only look at your first 2 terms. Common factor that. What number can I take out? What variable can I take out?
3.
Between 6 and 10, what can I remove? 2. Do I have M's to take out, C's to take out, or J's to take out? C's? Do we see that? Right there?
Oh.
Yeah, there's a C in both of them. So now I've removed I had a 6, I removed a 2. I divided out a 2. That leaves me with 3 and that M. I didn't mess around with the signs, and you won't on your first one, generally, unless it's negative. 10, I divide by 2, I get a 5. I took out the C, so I have a J left. So that is what's in my bracket. That is my goal. In the next one, I want to be left with a 3M minus 5J. Okay? I got a negative 3M plus 5J. I need it to be a 3M minus 5J. What's the only thing I need to remove?
Negative.
The negative. I'm going to take out a negative. But that's like removing a negative what?
1.
1. Otherwise, I don't have anything there, right? I need it. So I'm going to take out that negative as a negative 1. That flips this whole thing to positive 3M, which is what I want. And this negative or positive 5J will become the negative 5J that I want, because 2 negatives give me a positive. Now write down your factors. I'm going to go this one first this time. 2C minus 1. See how it's so important that 1's there? Because otherwise, what would my second half of my binomial be? And then, since they're identical, write down one of them. If they're not identical, you've done something wrong. Okay? They can be backwards. I'm going to show you something like, yeah, like this one. Let's just put it right here before I go to number 5. 2x squared plus 5x plus 5y plus 2xy. Again, I can't common factor. There's nothing that's all four of the terms have. Right? So again, I'm going to factor my first two. There will always be something that you can remove out of your first two. I have a 2 and a 5. That doesn't help me. I have an x squared and an x. What's the most I can take out? An x. Can't go squared, but I can go x. That will leave me with the 2 and one more x. And 5. So that is my goal, is to get a 2x and a positive 5. Or a positive 2x and a positive 5. Okay, so now looking at these two here, right? You will notice that you can take out a y. So if I take out a positive y, I'm left with the 5 and the plus 2x. Now, are those brackets actually the same? Yeah, they're just backwards, right? Do you see that 2x plus 5 and 2x plus 5? It's just backwards. That's all they are. Okay? So one of my binomials is an x plus y. My other binomial, I'm going to choose this guy here because he's in the proper order. Okay? All right, let's go up to 5. Okay? 6a squared plus 20bc minus 8ba minus 15ca. Okay? It's 4 terms, but I always check to see if I can common factor first. Anything common between 6, 20, 8, and 15? No. I don't have A's in all the terms. I don't have B's in all the terms. I don't have C's in all the terms. So the only method I could use is common factoring. Or sorry, is grouping. So I'm going to look at the first two terms. Okay. What's common there?
2.
That's pretty much it. What am I left with?
3.
3a squared plus a 10bc. Now I want to be left with a 3a squared plus a 10bc left over when I'm done factoring this thing. Is there any possibility that I can get that?
No.
No. All right. So sometimes they're out of order. Not out of order as you can't do it. Out of order as rearrange.
Oh my God.
Okay? So look at your coefficients here. Right? I have a 6 to 20 and 8 to 15. Right? I have a squareds. This one didn't even have an a in it. Right? I've got some others that, like b's are only in these two terms. A's are in these, this term, that term. Right? That sort of thing. So just rearrange the terms a different way, right? Don't put these two together. Put them together with something else. I'm going to go with this one, and it really makes no difference. Try a different one. Obviously, this term doesn't work, so try the last one. You want to do the last two first and the last together? Okay, let's try that. So I'm going to put the first two last together.
No.
And then I'm going to put these two next. 20bc minus an 8ba. Try that.
We have to try it.
All right, let's see what we got. So now, what's common between 6 and 15?
3a.
3a, that's better, right? We've got at least a number and a variable coming out this time. And I'm left with a
2a.
2a minus what?
5a.
5c. Okay.
Enough.
All right. Now let's look at the other one. I got a 20 and an 8.
I think we did it.
What do we got there? What's common between 20 and 8?
It would be
4 and a B. Okay. That leaves me with a 5
C.
and a C. Now, I didn't put a sign in here because at the moment, if I leave this as a positive, right, I end up with a positive 5C. Do I want a positive 5C?
Mine on negative.
I want a negative 5C, right? So what do I have to do here?
Change it to a negative.
Change it, pull out a negative here, and that will give me a negative here. Also, because 2 negatives give me a positive. Or I could just go back and flip these 2 terms around again, right? That would work too. So I get the negative 5C. The negative comes out. The 8 divides by 4 to give me a positive 2, which is exactly what I want.
Ha.
And I took the B out, so now I'm left with is the A. Are these 2 brackets identical now?
Yes.
Yeah, they're just backwards from each other, but they are identical. So now 3A minus 4B. The other combination would have also worked. This one, first and last, and the 2 middles. Or no, sorry, the first and this one, and these 2, 2s and 3s. It would have also worked. The only combination that didn't work was the way I had it. So sometimes, it's very rare that you have to reorder, but just be aware that sometimes you have to end up reordering. Okay? All right, here's the assignment.
Oh, it's short.
Yeah, it is only 2 pages. The
Let's
first,
go.
I want to look at number 5.
Primes.
Yeah, I'm going to look at number 5.
Oh my god.
The first 6
So hard.
are actually half of the factoring's been done for you. Okay, they're on step 2. They've already grouped it. They've already common factored the first part, and they've already common factored the second part. So when we put it together, the reason why I want to put these in here is this step right here. So I've got my 2 binomials. Every once in a while, after you're done grouping, you will notice that you can common factor. Every once in a while. Do you see that I have a 2f squared plus 6?
Yeah, I do see that.
Yep. Do you notice that it's has a common 2?
Yeah, wow.
So this one here actually common factors to give you this. And then you just write the other one. That had a common factoring.
Wait, do we have to write that?
Yes. Otherwise, that's not fully factored. It's factored once, it's grouped. So I did grouping, but then I needed to do common factoring after that. So there is combinations where you may, so if you miss the fact that there was a common factor in it, you'll notice it after you've grouped it. And you'll be able to take it out then. So if you happen to get a common factor or a grouping question that did common factor and you missed it, it'll show up looking like this, where one of your factors can be factored again. Okay? Not a big deal. Look at number 8. No, not number 8. Do I have one that looks like that? Let me just flip. No, I don't. I didn't put one in. Let me pick one here. One that looks like this. One more. I'm going to just do this one. This one right here. You can see that there's a common 2 in the whole thing, right? But let's say you didn't see that.
Oh, okay.
Okay? Let's say you went, oh, it's 4 terms. I'm just going to group it. Right?
Fair enough.
And you didn't see that there was, you could have pulled out a 2. Here's what's going to happen. So we're going to group the first 2. Right? I'm going to ignore the second half. I can remove, I'm just going to cover that up. Right? I can remove a 2 and an x, right? What am I left with? Y plus what?
3.
3. Good. Let's go over to this side. What can I remove?
4.
Positive or negative? Positive 4. And I'm left with the x plus, do I get a 3?
Yeah.
Yeah. So when I write it out, I get a 2x plus 4 and an x plus 3. Check your answers. Is there anything more I can do?
Yeah, there's a 2.
There's a 2. That's where it ended up, right? There's a 2 in both of these. It's a 2x plus 4. I can now common factor the 2 out and get an x plus 2. Because I missed it at the beginning, it'll show itself later on, and you can do it again.
Wait, why is there a y plus 3 and then an x plus
Oh, sorry, I missed.
3? You just put the wrong.
I just put the wrong variable.
Okay.
I'm thinking I put the wrong variable. Yes, I did. This should have been a y. There we go. I had the wrong variable. Thank you. There we go. So if you do happen to miss the common factoring, you will notice it later on in one of your answers. One of your binomials will be a double or a triple or a, it'll show it in there and you can get it out afterwards. So it's not like you're, if you don't catch it right away, that you're lost, that you got the answer wrong. You won't get the answer wrong. It's more work because your answer will be bigger to do, but in the end, you'll be able to pull it out later. And that's the one lovely thing about it. All right, that is your grouping assignment. There's a front page and a back. I think once you hit the later on ones, there's some backwards ones later on and ones that you have to rearrange later on. All right, 2 pages.
I'm ready to
Good
go to
luck.
this page.
Good, I will take